Hello students, this is chemistry video number 1, CET video number 1. So in video number 1, I will be explaining about the questions from the first chapter, that is the solid state. First question, which among the following show anisotropy? Options are A. Glass, B. Sodium bromide, C. Plastic, D. Rubber. So you know that solids can be classified into two types, crystalline solids and amorphous solids. Among these two types of solids, only the crystalline solids will show anisotropic nature. So example here, glass is not a crystalline solid, plastic is also not a crystalline solid, and rubber is also not a crystalline solid. But if you consider NaBr, it is an example for crystalline type of solid. Hence, the answer will be NaBr. So I'll move to next question. Second one. Which of the following form molecular solid when solidified? Options are A. Calcium fluoride, B. Silicon dioxide, C. Calcium dioxide, and D. Sodium chloride. So solids mainly can be classified into four categories: ionic solids, covalent solids, metallic solids, and molecular type of solid. And if you observe the example for each type of solid, so calcium fluoride is coming under example for ionic solid, and also sodium chloride is also a type of ionic solid. Silicon dioxide is an example for covalent or network type of solid, but this calcium dioxide, it is an example for molecular solid. Hence, our answer will be C. Calcium dioxide. Third question. Solid X is a very hard solid. It is electrical insulator in solid as well as in molten state and has high extreme melting point. What type of solid it is? So they are given a solid, let it be X, and the properties are it is very hard, it is electrical insulator in solid as well as molten state and having high melting point. Options A. Ionic solid, B. Covalent solids, C. Metallic solids, and D. Molecular solid. So here you have to consider the properties of each type of solid. First, to begin with ionic solid, so these are conductors in molten state. Hence this can be eliminated because here they mentioned that it is electrical insulator, so ionic solid can be eliminated. So option C, if you observe metallic solid, so these metallic solids are usually very good conductors in molten state as well as solid state. So this metallic solid can be eliminated. So remaining is D, molecular solids. So if you consider the properties of molecular solids, they are soft in nature, they will be having low melting points, obviously insulators, but since it is soft in nature and a low melting point, this cannot be matched with the properties of solid X, so D can be eliminated. So remaining is B. So covalent solid. So this property is shown by covalent solid. So solid X is a type of covalent solid. So answer is B, covalent solid. Next, fourth one. Which of the following does not represent a type of crystal system? Options A. Triclinic, B. Monoclinic, C. Rhombohedral, and D. Isotropical. So if you consider the type of crystalline system, triclinic is a crystalline system, type of crystalline system. Monoclinic is also a type of crystalline system. Rhombohedral is also a type of crystal system, but isotropical is not a crystal system. So answer would be isotropic, isotropical. So here you have to remember about the type of crystal systems. Question number 5. Example of few solids are given below. Find out the example which is not correctly matched. Options: A. Ionic solids, NaCl, zinc sulfide. B. Covalent solids, H2I2. C. Molecular solids, H2O. D. Metallic solids, copper and tin. So among these you have to choose the one option which is not correctly matched. For that you must have to remember the examples for each type of solids. So ionic solids, if you consider, so obviously NaCl and zinc sulfide are right example for ionic solids. So option A can be eliminated. If you observe option C, molecular solids, water is also an example for molecular solids. Hence option C can be eliminated. If you observe option D, metallic solids, so copper and tin are example for metallic solids. Hence this match is correct. D can be eliminated. So B, if you consider covalent solids, so H2 and I2 are not example for covalent solids, but these are example for molecular solids. Okay. So option B is not correctly matched. So answer is covalent solids. Sixth question. Graphite is a good conductor of electricity due to the presence of dash. Option A, lone pairs of electron. Option B, free valence electrons. Option C, cations. Option D, anions. So here you have to give the reason for the conductivity of graphite. So if you consider the structure of graphite, so in graphite, 6 carbon atom will form hexagonal ring. So those hexagonal ring, adjacent hexagonal rings are connecting to each other to form layers. So there will be formation of many number of layers. Between one and another layer, the fourth valence electron of carbon will move throughout the layer. So between adjacent layer, there will be movement of valence electron in the structure of graphite. So that is particularly fourth valence electron of carbon. So here due to that graphite will show conductivity property. So hence here the correct matching answer will be B, presence of free valence electrons in the structure of graphite which is moving throughout the structure. So, and this will be responsible for the electrical conductivity of graphite. So answer B, free valence electrons. Seventh question. The percentage of empty space filled in body-centered cubic arrangement is dash. Options A 74, B 68, C 32 and D 26. So here you have to consider the packing efficiency. So packing efficiency is nothing but percentage of total space filled by the particle. So for body-centered cubic arrangement, you know that packing efficiency is 68. That means out of 100, only 68 percentage is filled by the particle. So here, to calculate the empty space available, what you have to do? You have to subtract total, that is 100 minus filled space. Filled space is 68 in case of body center. So 100 minus 68 equal to 32. So hence the answer is C 32. Next question 8. Which of the following point defects are shown by AgBr crystals? Silver bromide crystals. Schottky defect, Frankel defect, metal excess defect and metal deficiency defect. So you have to remember this one that, so options are A first and second, B third and fourth, C first and third, and D second and fourth. So AGBR, you have to remember that it will show both Schottky defect as well as Frankel defect. So it is only one crystal which is example for showing both Schottky as well as Frankel defect. So our answer is A, 1 and 2. Question number 9. Silicon doped with electron-rich impurity forms dash. Options: A. P-type semiconductor, B. N-type semiconductor, C. Intrinsic semiconductor, D. Insulator. So you know that semiconductors can be classified into two types, intrinsic semiconductors and extrinsic semiconductors. Intrinsic semiconductors are nothing but these are the semiconductors which are having property of showing conductivity in some condition, that is at high temperature condition. For example, silicon. So sometimes it can behave as conductor. So semiconductor means some materials which are showing conductivity property at some conditions. Extrinsic semiconductor means conductivity of intrinsic semiconductor can be increased by doping the intrinsic semiconductor with some other elements. So those are pentavalent impurities or trivalent impurities. For example, if you take the silicon, it is having valency of 4. If you dope that with the trivalent impurity, it will form P type of semiconductor. So that trivalent impurity is called as electron deficient impurity. So if you dope silicon with the pentavalent impurity, that is called as electron rich impurity, it will give rise to N type of semiconductor. Insulators means materials which are not conducting at all. So here electron rich means we have to dope silicon with pentavalent impurity, that will give rise to formation of N type of semiconductor, where semiconductivity or conductivity is due to the movement of electrons within the structure. So hence answer is B, N type of semiconductor. Next, 10th question. Which of the following statements is not true about the hexagonal close packing? Option A, the coordination number is 12. Option B, packing efficiency is 74%. Option C, tetrahedral walls of second layer is covered by the spheres of the third layer. Option D, the spheres of fourth layer are exactly aligned with those of first layer. So here you have to choose an option which is not true about the hexagonal close packing. So we will see one by one. Option A, we should consider the coordination number is 12. So it is correct one. It is matching with the hexagonal close packing structure. So it is having coordination number of 12. And B option, packing efficiency is 74. Obviously, you know that in hexagonal close packing, the packing efficiency is 74. So this is true for the hexagonal close packing. So option A and B are eliminated. C, tetragonal voids of second layer are covered by the spheres of the third layer. So here you have to consider the structure of hexagonal close packing. So if you observe the structure, you will be able to find out that tetrahedral voids of second layer are covered by the spheres of the third layer. It is holds good. It is true. But if you consider the option D, the spheres of fourth layer are exactly aligned with those of the first layer. So this is not a true statement with respect to the hexagonal close packing. But all the three A, B, C are true statements about the hexagonal close packing. Hence our answer is D. The spheres of fourth layer are exactly aligned with those of the layer. So this statement is not holding good for the hexagonal close packing. Okay, thank you.